Now, in this lecture, we will answer on two questions. The first question is to find out the diameter of this circle, the orange circle, and the second question is to find out the size of this angle theta. So we'll start with the first question. In the drawing we have three semicircles. The biggest semicircles consist two small semicircles and one orange circle. We know that the diameter of this semicircle is equal to 10 units. Therefore, the radius is equal to 5 units. We also know that the diameter of this semicircle is equal to 20 units. Therefore, the radius of this semicircle is equal to 10 units. And the diameter of the biggest semicircle, this semicircle, is equal to 10 plus 20 units. That is to say, the diameter is equal to 30 units. Therefore, the radius of the biggest semicircle is equal to 15 units. And we want to find out the diameter of the orange circle. So we will define the radius of the orange circle as R. We'll write it down. R is the radius of the orange circle, and the center of the orange circle is at point C, this point, and we will define the center of this, the smallest semicircle, as point X. We will define the center of the biggest semicircle, this semicircle, as point Y, and we define the center of this semicircle as point Z. In the next step, we will join together the centers of the semicircles with the center of the orange circle that is at point C, this point. And I will present to you two new rules about tangency between two circles. Actually, two circles can touch each other at one point in two different ways. The first type of tangency between two circles is the external nudge, like in this drawing. Those two circles are touching each other at this point. This is the point of tangency between those two circles. The center of the small circle is at point M, and the radius of this small circle is equal to small r, while the center of the big circle is at this point, point O, and the radius of this big circle is equal to capital R, and the distance between the centers of those two circles, that is to say the length of line segment MO, will be equal to the sum of the lengths of the radii. That is to say, it will be equal to capital R plus small r. So in conclusion, we can say that whenever there is an external lunge between two circles, then the distance between their centers will be equal to the sum of the lengths of their radii. And there is also another type of tangency between two circles, that is to say two circles can touch each other in a different way, and that is defined as the internal lunge. In the internal lunge, those two circles touching each other internally at this point. This is the point of tendency, and in this case the distance between the centers of the two circles, that is to say the length of line segment OM or MO, it will be equal to the difference between the lengths of their radii. That is to say, it will be equal to capital R minus small r. So OM, the distance, is the difference between the lengths of their radii. That is to say, it equals to capital R minus small r. In conclusion, when two circles are touching each other externally, like in this drawing, then the distance between their centers will be equal to the sum of the lengths of their radii. In this case, it will be equal to capital R plus small r, while and this is the external lunge, while if two circles are touching each other internally, then it is defined as internal lunge, and then the distance between their centers will be equal to the difference between the lengths of their radii. In this case, it will be equal to capital R minus small r. Okay? So we'll use those two new rules in order to calculate the lengths of the line segments that we created here. So what is the length of line segment XC or CX? CX, actually C is the center of the orange circle and its radius is R. X is the center of this semicircle with radius of 5 units. And those two semicircle and circle has an external lunge between them at this point. That is to say, they are touching each other externally at this point. This is the point of tendency between the circle and the semicircle. And whenever you have an external lunge between two circles or semicircles, then the distance between their centers will be equal to the sum of the lengths of their radii. That is to say, it will be equal to the radius of this orange circle, that is R, plus the radius of this small semicircle, that is 5. In total, it will be equal to R plus 5. So in conclusion, we found out that the length of line segment CX is equal to R plus 5. Okay? Likewise, we'll calculate the length of line segment CY. Here C is the center of the orange circle with radius R. Y is the center of the biggest semicircle with radius 15. and the biggest semicircle and the orange circle have an internal notch between them at this point. That is to say, they are touching each other internally at this point, and whenever you have two circles that have an internal notch between them, then the distance between their centers will be equal to the difference between the lengths of their radii. So it will be equal to the radius of the biggest semicircle, that is 15 units, minus the radius of this orange circle, that is r. So in conclusion, we found out that the length of line segment CY is equal to 15 minus r. Likewise, we will calculate the length of line segment CZ. Here, C is the center of the orange circle with radius r. Z is the center of this semicircle with radius 10. The orange circle and this semicircle have an external notch between them at this point. That is to say, they are touching each other externally at this point. This is the point of tendency. Therefore, whenever you have an external notch between two circles or semicircles, then the distance between their centers will be equal to the sum of the length of their radii. That is to say, the radius of this orange circle is r, and the radius of this semicircle is 10, and the distance between their centers will be equal to the sum of the length of the radii. That is to say, it will be equal to r plus 10 units. So we found out that line segment CZ equals to r plus 10 units. Likewise, we calculate the value of line segment XY. X is the center of the smallest semicircle, this smallest semicircle with radius 5. Y is the center of the biggest semicircle with radius 15, and the smallest semicircle and the biggest semicircle have an internal notch between them at this point, point A, and whenever we have two circles or semicircles with an internal notch between them, then the distance between their centers, that is to say xy, will be equal to the difference between the lengths of their radii. The radius of the biggest semicircle is 15, and the radius of the smallest semicircle is 5, and the difference between the lengths of their radii is 15 minus 5, that is 10. So we found out that the length of line segment xy equals to 10 units. Likewise, we'll find out the value of line segment xz. X is the center of the smallest semicircle with radius 5. Z is the center of this semicircle with radius 10 units. And those two semicircles have an external notch between them at this point, point P, that is to say, they are touching each other externally at point P. And whenever you have two semicircles or circles that have an external notch between them, then the distance between their centers will be equal to the sum of the lengths of their radii. That is to say, it will be equal to the radius of the smallest semicircle 5, that is 5, plus the radius of this semicircle that is 10. So 5 plus 10 is 15. So we found out that the length of line segment XZ is equal to 15 units. So we found out all the lengths of all the line segments in this drawing. So in the next step I will present to you a new law that is actually the law of cosines. The law of cosines is true in any triangle. You can use it in any triangle. So what is the law of cosines? If we have a triangle ABC, that could be any triangle. And we know that side AB of triangle ABC equals to A units in its length, side BC equals to B units in its length, and side AC equals to C units in its length. And we also know that the angle between side AB and side BC is theta. Then, according to the law of cosines, we will get that C squared is equal to A squared plus B squared minus 2 times AB times cosine theta. You can use this equation in any triangle. You can implement the law of cosines in any triangle. So actually the Pythagoras theorem is a special case of the law of cosines. So the general rule is the law of cosines, and the special case of the law of cosines is the Pythagoras theorem when theta equals to 90 degrees. When angle theta equals to 90 degrees, then we will get a right triangle. And here in the equation, cosine of 90 degrees is 0. 0 times anything is 0. So this expression minus 2ab cosine theta will be equal to 0. And we left only with the equation that c squared equals to a squared plus b squared. That is exactly the Pythagoras theorem that says that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in conclusion, the Pythagoras theorem is the special case of this law, the law of cosines, when theta equals to 90 degrees. Okay, so we will implement the law of cosines in our triangle XCY. So I will copy triangle XCY in a new page, and we will implement the law of cosines in this triangle XCY. So here we have this is triangle CXY. I copied it from the original drawing. We have already found out that CX is equal to R plus 5 units. We have already found out that the length of line segment xy is equal to 10 units, and we have already found out the length of line segment cy equals to 15 minus r units, and this is angle theta. So according to the law of cosines, we will get, this will be equation number 1. We get that the law, according to the law of cosines, cy squared equals to cx squared plus xy squared minus 2 times cx times xy times cosine theta. Okay? In the next step, we will substitute cy by 15 minus r. We will substitute cx by r plus 5, and we will substitute xy by 10 in equation number 1, of course, and we get that according to equation number 1, cy squared equals to 15 minus r squared, and it equals to cx squared, that is r plus 5 squared, plus xy squared, that is 10 squared, minus 2 times cx, that are r plus 5, times xy, that is 10, times cosine theta. So we will open the brackets on both sides of equation number 1, and we'll get that according to equation number 1, 15 minus r squared equals to 15 squared, that is 225, plus r squared minus 2 times 15r is minus 30r. And it is equal to r plus 5 squared. R plus 5 squared equals to r squared plus 5 squared, that is 25, plus 2 times r times 5 is plus 10r, plus 100 squared, that is plus 10 squared, that is 100, minus 2 times 10 is minus 20 times r plus 5 times cosine theta. Here we have r squared on both sides of equation number 1, so r squared will get cancelled. So what is left from equation number 1 after we cancelled r squared? What is left is that in this side we have 225 minus 30r, and in the other side of equation number 1 we have 25 plus 100 is 125, plus 10r, minus 20 times r plus 5 times cosine theta. Here we will subtract 125 from this equation, equation number 1. So 225 minus 125 is 100. We will also subtract 10r from this equation, equation number 1, and we get that minus 30r minus 10r is minus 40r. And it is equal to minus 20 times r plus 5 times cosine theta. Here we will multiply equation number 1 by minus 1. And we'll get that according to equation number 1, 100 times minus 1 is minus 100. Minus 40r times minus 1 is plus 40r. And minus 20 times minus 1 is plus 20 times r plus 5 times cosine theta. Here we will divide the equation number 1 by 20 times r plus 5. And we'll get that according to equation number 1, cosine theta equals to 40r minus 100 over 20 times r plus 5. Here we will divide both the numerator and the denominator of this side of equation number 1 by 20, and we get that 40r over 20 is 2r, minus 100 over 20 is minus 5, 20 over 20 is 1, so in the denominator we have only left with r plus 5. So in conclusion, we found out that according to equation number 1, cosine theta is equal to 2r minus 5 over r plus 5. In the next step, I will copy triangle CXZ in this new page, and we will implement the law of cosines in triangle CXZ. This is triangle CXZ, so I'll copy it to this new page, and we will implement the law of cosines in triangle CXZ. We have already found out that Cx equals to r plus 5, xz equals to 15 units, and cz equals to r plus 10, according to the law of cosines. We will get that this will be equation number 2. Cz squared equals to cx squared plus xz squared minus 2 times cx times xz times cosine theta. In the next step, we will substitute cz by r plus 10, we will substitute cx by r plus 5, and we will substitute xz by 15 in equation number 2, of course. And we get that according to equation number 2, cz squared, cz equals to r plus 10, so cz squared will be equal to r plus 10 squared, and it is equal to cx squared. Cx equals to r to r plus 5, so cx squared will be equal to r plus 5 squared plus xz squared. Xz equals to 15, so xz squared equals to 15 squared. 15 squared is 225. Minus 2 times cx is r plus 5 times xz is 15 times cosine theta. So we will open the brackets on both sides of equation number 2, and we get that according to equation number 2, r plus 10 squared equals to r squared plus 10 squared, that is 100, plus 2 times r times 10 plus 20, it is 20r. And it is equal to r plus 5 squared, that is r plus 5 squared is r squared plus 5 squared is 25 plus 2 times r times 10 is 20r plus 225 minus 2 times 15 is minus 30. Minus 30 times r plus 5 times cosine theta. Here we have r squared on both sides of equation number 1, so r squared will get cancelled. And what is left from equation number 2, after we cancelled r squared, what is left is actually, in this side we have 100 plus 20r, and on the other side of equation number 2 we have 25 plus 225 is 250 plus 20r minus 30 times r plus 5 times cosine theta. Here we will subtract 250 from this equation, and we get that 100 minus 250 is minus 150. We will also, here it is actually r plus 5 squared, it is, here we will have only 10r, it is 10r and not 20r, here it is 10r and not 20r, okay, so we will subtract 10r from equation number 2, and we will get that 20r minus 10r is 10r, and it is equal to minus 30 times r plus 5 times cosine theta. Here 10r, 20r minus 10r, it is 10r and not minus 10r, so fix it. Here we will multiply equation number 2 by minus 1. And we get that according to equation number 2, minus 150 times minus r is plus 150. 10r minus 1 is minus 10r, and minus 30 times minus 1 is plus 30. 30 times r plus 5 times cosine theta. Here we will divide equation number 2 by 30r plus 5, and we'll get that according to equation number 2, cosine theta is equal to 150 minus 10r over 30 times r plus 5. Here we will divide this side of equation number 2, both the numerator and the denominator, by 10, and we will get that 150 over 10 is 15, minus 10r over 10 is minus r, and 50 over 10 is 3. So in conclusion, we found out that according to equation number 2, tangent theta according to equation number 2, cosine theta equals to 15 minus r over 3 times r plus 5, while according to equation number 1, we have already found out that cosine theta is equal to 2r minus 5 over r plus 5. Okay, so we have two different expressions for cosine theta. In the next step, we'll create equation number 3 that states that cosine theta according to equation number 1 must be equal to cosine theta according to equation number 2. So cosine theta according to equation number 1 is 2r minus 5 over r plus 5, and it must be equal to cosine theta according to equation number 2, that is actually 15 minus r over 3 times r plus 5. Here we will multiply equation number 3 by r plus 5, so r plus 5 will get cancelled from the denominator, and we will multiply equation number 3 by 3, and we will get that according to equation number 3, 3 times 2r minus 5 is equal to 15 minus r. We will open the brackets on this side of equation number 3, and we will get that according to equation number 3, 3 times 2r is 6r, and 3 times minus 5 is minus 15. It equals to 15 minus r. Here we will add to equation number 3 r, and we will add to equation number 3 also 15, and we will get that according to equation number 3, 6r plus r is 7r, 15 plus 15 is 30. So in conclusion, we found out that according to equation number 1, 7r equals to 30. Here, according to equation number 3, of course, 7r equals to 30. Here we will divide equation number 3 by 7, and we will get that according to equation number 3, r equals to 30 over 7 units. So the radius of the orange circle equals to 30 over 7 units, and we actually want to find out the diameter of the orange circle, the diameter is twice as large as the radius, so we will multiply the radius by 2 and we will get the diameter of the orange circle. So the diameter of the orange circle is equal to 2r, that is to say it is equal to 2 times r, and r is 30 over 7. 2 times 30 is 60, so in conclusion we found out that the diameter of the orange circle is equal to 60 over 7 units, or in terms of numbers it is equal to 8.5714 units. We repeat again. The diameter of this orange circle, it is equal to either 60 over 7 units, or in terms of numbers it equals to 8.5714 units. In the next step I will summarize the lecture. Actually we wanted to find out the radius of this orange circle. We have in the drawing 3 semicircles. The biggest semicircle contains the 2 small semicircles and the orange circle, and we want to find out the diameter of the orange circle. So first of all, we defined the center of the orange circle as C, the center of this semicircle as X, the center of the biggest semicircle as Y, and the center of this semicircle as Z. Then we join together the centers of the semicircles with point C. This is the center of the orange circle, and I presented to you 2 new rules in relation to the tangency between 2 circles. 2 circles can touch each other in 2 different ways. The first type of tangency is the external tangency, when the 2 circles are touching each other externally, like in this drawing. Then, so this is the point of tangency between the 2 circles. Then it is defined as the external lunge, and the distance between the centers of those 2 circles will be equal to the sum of the length of the R and the I, that is to say it will be equal to capital R plus small r. So in the external tangency, whenever 2 circles are touching each other, then the distance between their centers will be equal to the sum of the length of the R and the I. In this case it is capital R plus small r. And we have a second type of tangency between 2 circles. 2 circles can touch each other also internally, and then it is defined as the internal lunge. And in the internal lunge, the distance between the centers of the 2 circles, that is to say the length of line segment MO, will be equal to the difference between the lengths of the R and the I. In this case, it will be equal to capital R minus small r. Okay, so we implemented the 2 rules in our drawing. We found out the value of line segment CX. C is the center of the orange circle with radius R. We define the radius of the orange circle as R. X is the center of the smallest semicircle, this semicircle with radius 5. And those 2 circle and semicircle have an external lunge between them at this point, that is to say they are touching each other externally at this point, and whenever 2 circles are touching each other externally, then the distance between their centers will be equal to the sum of the length of the R and the I. In this case it will be equal to R plus 5. So we found out that Cx equals to R plus 5, Likewise, we found out the value of cy. C is the center of the orange circle with radius r. Y is the center of the biggest semicircle with radius 15. And those two semicircle and circle have an internal knot between them at this point. That is to say, they are touching each other internally at this point. And whenever two circles are touching each other internally, then the distance between their centers will be equal to the difference between the lengths of their radii. In this case, it will be equal to the radius of the biggest semicircle, that is 15, minus the radius of the orange circle, that is r. So in conclusion, we found out that cy equals to 15 minus r. Okay, likewise, calculated the value of line segment cy. We calculate the value of line segment cz. Cy equals to 15 minus r, of course. cz, c is the center of the orange circle with radius r. Z is the center of this semicircle with radius 10. Those two circle and semicircle have an external knot between them at this point. That is to say, they are touching each other externally at this point. And whenever we have two circles that are touching each other externally, then the distance between their centers will be equal to the sum of the length of their radii. In this case, it will be equal to the radius of this orange circle, that is r, plus the radius of this semicircle, that is 10. That is to say, cz equals to r plus 10. Likewise, we found out the value of line segment xy. X is the center of this semicircle with radius 5, and y is the center of the biggest semicircle with radius 15. Those two, the smallest semicircle and the biggest semicircle, have an internal knot between them at this point, point A. Therefore, the distance between their centers will be equal to the difference between the lengths of their radii. That is to say, it will be equal to the radius of this biggest semicircle, that is 15, minus the radius of the smallest semicircle, that is 5. 15 minus 5 is 10. So we found out that xy equals to 10 units. Likewise, we found out the value of line segment xz. Again, x is the center of the smallest semicircle with radius 5. Z is the center of this semicircle with radius 10. Those two semicircles have an external knot between them at this point, point P, that is to say, they are touching each other externally. They have external knots at this point, that is to say, they are touching each other externally at this point, point P. And whenever you have two circles of semicircles with an internal knot between them, then the distance between their centers will be equal to the sum of the length of their radii. That is to say, it will be equal to the radius of this semicircle, that is 5, plus the radius of this semicircle, that is 10. 5 plus 10 is 15. So we found out that xz equals to 15 units. In the next step, I presented to you a new law that is actually the law of cosines. The law of cosines is true in any triangle. So if you have triangle ABC, that could be any triangle. We know that side AB of triangle ABC equals to A units in its length, side BC equals to B units in its length, and side AC equals to C units in its length. Then, according to the law of cosines, C squared equals to A squared plus B squared minus 2 times AB times cosine theta. Okay? And I also mentioned that the Pythagoras theorem is a special case of the law of cosines. When angle theta equals to 90 degrees, when angle theta equals to 90 degrees, then triangle ABC will be a right triangle. And here cosine 90 degrees is 0. 0 times 2AB is also 0. And we left only the expression that c squared equals to a squared plus b squared. And this is exactly the Pythagoras theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. In conclusion, the Pythagoras theorem is a special case of the law of cosines when theta equals to 90 degrees, and then we are talking on a right triangle. Okay, so we implemented the law of cosines in our triangle CXY, so I copy triangle CXY in a new page, and we implemented the law of cosines in this triangle CXY. We have already found out that Cx equals to r plus 5, xy equals to 10, cy equals to r 15 minus r, and here, according to the law of cosines, we will get that cy squared equals to cx squared plus xy squared minus 2 times cx times xy times cosine theta. This is equation number 1. Then we substituted cy by 15 minus r, we substituted cx by r plus 5, and we substituted xy by 10. So we got that according to equation number 1, 15 minus r squared equals to r plus 5 squared plus 10 squared minus 2 times r plus 5 times 10 times cosine theta. We open the brackets on both sides of equation number 1, and we got that 15 minus r squared equals to 15 squared, that is 225, plus r squared minus 2 times 15 times r, that is minus 30r. And r plus 5 squared equals to r squared plus 5 squared, that is 25, plus 2 times r times 5, it is 10r, plus 100 squared is 100, minus 200, minus 2 times 10 is minus 20 times r plus 5 times cosine theta. Here we have r squared on both sides of the equation, so r squared will get cancelled. What is left after we cancelled r squared from equation number 1? What is left is actually in this side we have 225 minus 30r, and in the other side of equation number 1, what is left, it is actually we have 25 plus 100 is 125, and we also have 10r, and we have here minus 20 times r plus 5 times cosine theta. So here we subtracted 125 from equation number 1. 225 minus 125 is 100. We subtracted also 10r from this equation number 1. 30r minus 30r minus 10r is minus 40r. And what is left in the other side of the equation? What is left is actually only minus 20 r plus 5 times cosine theta. We multiplied the equation number 1 by minus 1, and we got that according to equation number 1, 100 times minus 1 is minus 100, minus 40r times minus 1 is plus 40r. So in conclusion, we found out that 40r minus 100 equals to minus 20 times minus 1 is plus 20. So here we have 20 times r plus 5 times cosine theta. We divided the equation number 1 by 20 times r plus 5, and we got that according to equation number 1, cosine theta equals to 40r minus 100 over 20 times r plus 5. Here we divided this equation, this side of equation number 1, both the numerator and the denominator, by 20, and we got that 40r over 20 is 2r, minus 100 over 20 is minus 5, so in the numerator we have 2r minus 5, and here 20 over 20 is 1, so in the denominator what is left, it is actually r plus 5. So in conclusion, we found out that according to equation number 1, cosine theta is equal to 2r minus 5 over r plus 5. We did the same thing we implemented the law of cosines on triangle CXZ also. So I copy triangle CXZ in this new page, And we implemented the law of cosines in this triangle CXZ. We already know that CX equals to R plus 5, XZ equals to 15, and CZ equals to R plus 10. So according to the law of cosines, we will get that CZ squared equals to CX squared plus XZ squared minus 2 times CX times XZ times cosine theta. This is equation number 2. Then we substituted Cx by R plus 5, we substituted Cz by R plus 10, and we substituted Xz by 15. And we got that according to equation number 2, R plus 10 squared equals to R plus 5 squared plus 15 squared is 225 minus 2 times R times 15 times cosine theta. We open the brackets on both sides of equation number 2 and we got that R plus 10 squared equals to R squared plus 10 squared, that is 100, plus 2 times R times 10, that is actually 20R. And here we have R plus 5 squared, that is R squared plus 5 squared, that is 25, plus 2 times R times 5 is plus it is R squared plus 25. Here it is actually 10R. It is 10R. So here we have plus 10R minus 15 squared, that is 225, minus 30 times R plus 5 times cosine theta. Here we have R squared on both sides of equation number 2, so R squared will get cancelled. And what is left, it is actually 100 plus 20R equals to 250 plus 10R minus 30 times R plus 5 times cosine theta. Here we subtracted 250 from equation number 1, so 100 minus 250 is minus 150, and we also subtracted 10R from equation number 1, so 20R minus 10R is 10R. And what is left from equation number 2 after we did these operations, we have here, what is left is actually minus 150 plus 10R equals to minus 30 times R plus 5 times cosine theta. Here we multiply the equation number 1, equation number 2 by minus 1, and we got that minus 150 times minus 1 is plus 150, 10R times minus 1 is minus 10R, and minus 30 times minus 1 is plus 30. So in conclusion, we found out that according to equation number 2, 150 minus 10R equals to 30 times R plus 5 times cosine theta. Here we divided equation number 2 by 30 times R plus 5, and we got that according to equation number 2, cosine theta equals to 150 minus 10R over 30 times R plus 5. Here we divided both the numerator and the denominator on this side of equation number 2 by 10, and we got that 150 over 10 is 15, 10R over 10 minus 10R over 10 is minus R, and here 30 over 10 is 3. So in conclusion, we got that cosine theta equals to 15 minus R over 3 times R plus 5. I'll repeat again. According to equation number 2, we found out that cosine theta equals to 15 minus R over 3 times R plus 5. But according to equation number 1, we have already found out that cosine theta equals to 2R minus 5 over R plus 5. So we have two different expressions from cosine theta. Then we created equation number 3 that states that cosine theta according to equation number 1 must be equal to cosine theta according to equation number 2. Cosine theta according to equation number 1 is 2R minus 5 over R plus 5, and it must be equal to cosine theta according to equation number 2, that is 15 minus R over 3 times R plus 5. Here we have R plus 5. We multiply the equation number 3 by R plus 5, so R plus 5 in the denominator will get cancelled on both sides. And then we multiply the equation number 3 by 3, and we got that 3 times 2R minus 5 equals to 15 minus R. We open the brackets on this side of equation number 3. and we got that 3 times 2r is 6r, and 3 times minus 5 is minus 15. So in conclusion, we got that according to equation number 3, 6r minus 15 equals to 15 minus r. We added to this equation number 3r, and we also subtracted, added also 15. 6r plus r is 7r, 15 plus 15 is 30. So in conclusion, we got that according to equation number 3, 7r equals to 30. We divided the equation number 3 by 7, and we got that the radius r of the orange circle equals to 3 over 7 units, but we want to find out the diameter. The diameter is twice as large as the radius, so the diameter of the orange circle is equal to 2 times the radius. 2 times the radius is 2 times 30 over 7, because r equals to 30 over 7, and 2 times 30 over 7 is 60 over 7. So in conclusion, we found out that the radius of this orange circle is equal to, actually the diameter of this orange circle is equal to either 60 over 7 units, or in terms of numbers, it equals to 8.5714 units. We finished with the first question. In the next step, I will present to you how to find out the value of angle theta, or the side of angle theta. In the drawing, we have a quarter circle. This is a quarter circle. Inside this quarter circle, we have a square ABCO. We also have angle AMB that is equal to 90 degrees. And we have also angle BQC that is equal to theta. And this is the angle that we are looking for. We want to find out the size of angle theta. In order to find out the size of angle theta, we will make a construction. We will extend line segment MA by a straight line, and we will also extend line segment QO by a straight line until they intersect with each other. Okay? And we will define the intersection point between extended line segment MA and extended line segment QO as N. In the next step, we will complete the quarter circle to a semicircle. So we created a semicircle, and in this inside this semicircle we have the peripheral angle NMQ that is equal to 90 degrees, and we have rule number 1 that is related to a peripheral angle that is equal to 90 degrees. I will write it down. According to rule number 1, any peripheral angle that is equal to 90 degrees must rest on the diameter. So I read rule number 1 again. According to rule number 1, any peripheral angle that is equal to 90 degrees must rest on the diameter. So here in our drawing we have the peripheral angle NMQ that is equal to 90 degrees. Therefore, according to rule number 1, it must rest on the diameter. And the peripheral angle NMQ rests on NQ. That is to say, according to rule number 1, NQ is the diameter. We conclude that according to rule number 1, line segment NQ is the diameter of the semicircle. Okay, NQ is the diameter of the semicircle. We know, actually here we know that this is a quarter circle. This is a quarter circle according to what is given as the question. And because of the fact that this is a quarter circle, then line segment QO must be equal to the radius of the quarter circle. We'll define the radius of the quarter circle as R, capital R. So QO must be the radius of the quarter circle, that is to say it equals to R according to our definition. And actually O, it also must be the center of the semicircle and the center of the quarter circle. And we know that NQ is the diameter of the semicircle according to rule number 1. So NQ must be equal to 2 times the radius. That is to say, it must be equal to 2 times capital R. We know that QO is equal to R because we are talking about a quarter circle, and in quarter circle QO must be the radius of the quarter circle or the radius of the semicircle also. And what is the value of NO? From the drawing, it is very easy to see that the value of line segment NO, it is equal to NO, here NO, the value of line segment NO will be equal to QN minus OQ. QN minus OQ. Okay? So NO equals to QN, that is 2R, minus OQ, that is R. And 2R minus R is R. So we found out that NQ equals to R. NQ equals to R. It is actually NO. Here, NO equals to R. Again, NO equals to QN minus QO. So NU equals to QN, that is 2R, minus QO, that is R. 2R minus R is R. So we found out that NO equals to R. Here NO equals to R, that is the radius of the semicircle and the quarter circle also. In the next step, we will focus On the right triangle, triangle NMQ. In the right triangle, triangle NMQ, we know that the sum of the angles in any triangle is equal to 180 degrees. That is to say, this angle that is equal to 90 degrees plus this angle that is equal to theta plus this angle that is actually angle M and Q. In total, the sum of those three angles must be equal to 180 degrees. I repeat again, in the right triangle, triangle NMQ, the sum of the angles must be equal to 180 degrees. That is to say, 90 degrees plus angle theta plus the size of angle M and Q. In total, they must be equal to 180 degrees. We'll subtract 90 degrees from this equation, and we'll get that 90 degree theta plus angle M and O equals to 180 degrees minus 90 degrees, it is 90 degrees. Here we'll subtract theta from this equation, and we get that the missing angle, that is actually angle M and O, angle M and O is equal to 90 degrees minus theta. So we found out that angle M and O equals to 90 degrees minus theta. We write down that this angle M and O equals to, well, it is actually M and Q, it doesn't matter, so angle M and this angle M and Q equals to 90 degrees minus theta. Is also right to say, correct to say, that is angle M and O equals to 90 degrees minus theta. This is the missing angle. And we also know that all the angles inside a square are right angles, so all the angles, the four angles inside square ABCO must be equal to 90 degrees. So here we will create four angles, four right angles, and we found out that NQ, line segment NQ, is the diameter of the semicircle. Therefore, NQ as diameter must be a straight line. NQ must be a straight line because it is a diameter. Must be a straight line. Okay, NQ must be a straight line. So we have also rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 90 degrees. I'll write it down. The sum of the angles on one side of a straight line is equal to 180 degrees. So actually, if you focus on the upper side of the straight line NQ, it's point O, then the sum of the angles on the upper side of NQ at point O must be equal to 180 degrees. Which angles we have at the upper side of NQ at point O? We have here 90 degrees. And we also have here angle AON. In total, the sum of those two angles must be equal to 180 degrees according to rule number 2. I repeat again. On the upper side of the straight line NQ at point O, the sum of the angles must be equal to 180 degrees according to rule number 2. Which angles we have at point O? On the upper side of NQ we have 90 degrees and we have also angle AON. In total, the sum of those two angles must be equal to 180 degrees according to rule number 2. We will subtract 90 degrees from this equation and we get that angle AON, the missing angle, is equal to 180 degrees minus 90 degrees, it is 90 degrees. So we found out that the missing angle AON is equal to 90 degrees. So we can, so here a right angle, it is equal to 90 degrees. Likewise, we focus on the upper side of the straight line NQ at point C. Here at point C, on the upper side of the straight line NQ, the sum of the angles must be equal to 180 degrees. Which angles we have at point C? We have here 90 degrees plus angle OBCQ. In total, the sum of those two angles must be equal to 180 degrees according to rule number 2. I'll repeat again. On the upper side of the straight line NQ at point C, the sum of the angles must be equal to 180 degrees according to rule number 2. Which angles we have at point C on the upper side of NQ? We have 90 degrees plus angle BCQ. In total, the sum of those two angles must be equal to 180 degrees. We will subtract 90 degrees from this equation and we get that angle BCQ, the missing angle, is equal to 180 degrees minus 90 degrees, it is 90 degrees. So we found out that angle BCQ is a right angle, it is equal to 90 degrees. Angle BCQ is a right angle that is equal to 90 degrees. We will continue to focus on the right triangle BCQ. In the right triangle BCQ, the sum of the angles must be equal to 180 degrees. Which angles we have? In the right triangle BCQ, we have here 90 degrees. Plus this angle that is angle theta, plus this angle that is angle CBQ. In total, the sum of those three angles must be equal to 180 degrees. According to the rule that the sum of the angles in any triangle is equal to 180 degrees. Okay, so here I'll repeat again. In the right triangle BCQ, the sum of the angles must be equal to 180 degrees. That is to say 90 degrees plus angle theta plus the third angle that is angle CBQ. In total, the sum of those three angles must be equal to 180 degrees. We subtract 90 degrees from this equation and we'll get that according to this equation, theta plus angle CBQ must be equal to 180 degrees minus 90 degrees, it is 90 degrees. We will subtract theta from this equation and we will get that angle CBQ is equal to 90 degrees minus theta. Okay, we found out that the missing angle, angle CBQ, is equal to 90 degrees minus theta. We can write here that this angle equals to 90 degrees minus theta. Likewise, in the right triangle A and O, the sum of the angles must be equal to 180 degrees. So which angles we have in triangle A and O? We have here 90 degrees. We have also angle, this angle that is equal to 90 degrees minus theta. And we have also, this is the missing angle, angle OAN. Angle OAN. In total, the sum of those three angles must be equal to 180 degrees. The sum of the angles in the right triangle NO and AO must be equal to 180 degrees. That is to say 90 degrees plus the second angle that is equal to 90 degrees plus theta plus the size of the fourth angle that is actually angle ON. In total, they must be equal to 180 degrees. 90 degrees plus 90 degrees is 180 degrees. We have 180 degrees on both sides of the equation, so 180 degrees will get cancelled. And we left only with minus theta plus angle OAN that is equal to 0. Here we will add theta to this equation, and we will get that the missing angle OAN is equal to theta. Okay, we found out that the missing angle equals to theta, so we can write here that this angle OAN equals to theta. And we actually found out that all the angles of the right triangle A and O can go into all the angles of the right triangle BCQ. Why? Because both those two triangles have angle theta, both those two triangles have angle that is equal to 90 degrees minus theta, and both those two triangles have angle that is a right angle. It is equal to 90 degrees. Therefore, we can conclude from it that the right triangle A and O is similar to the right triangle BCQ, according to angle similarity rule. I will repeat again. From the fact that those two triangles have the same angles, equal angles, we conclude that the right triangle A and O is similar. This is the sign of similar to the right triangle BCQ. To the right triangle BCQ, according to angle similarity rule. And from the fact that those two triangles are similar to each other, we will conclude that the following relationship exists between their sides. We will conclude that CQ over OA is equal to BC over NO. I'll repeat again. We conclude that CQ over AO equals to BC over NO. What is the value of CQ? CQ from the drawing, you can see that the value of line segment CQ, it is equal to OQ minus OC. I repeat again, CQ equals to OQ minus OC. So CQ is equal to OQ, that is R, minus OC, we define OC as A. Okay, so in conclusion, we found out that CQ equals to R minus A, so according to our definition, OC equals to A, and we have, because of the fact that square A, B, C, O, all of its sides are equal to each other, therefore all the sides here will be equal to A in their lengths. So we found out that CQ equals to R minus A. So now we can substitute CQ in equation number 1 by R minus A. We'll do it now and we'll get that CQ is R minus A over OA. We found out that OA equals to A, and it is equal to BC. What is the value of BC? BC also equals to A over NO. The value of NO is R. So in conclusion, we found out that according to equation number 1, R minus A over A equals to A over R. So here we will split this expression to two parts. R minus A over A equals to R over A minus A over A, that is minus 1, and it is equal to A over R. Okay, so in conclusion, we found out that according to equation number 1, R over A minus 1 equals to A over R. We will focus on the right triangle, triangle AON. In the right triangle, triangle AON, we know that tangent theta is equal to R over A. Tangent theta equals to R over A. Okay, tangent theta in the right triangle, triangle AON, tangent theta equals to R over A. So we can substitute R over A in this equation, equation number 1, by tangent theta. We'll do it now and we'll get that according to equation number 1, R over A is tangent theta. That is equal, actually it is R over A minus 1 is equal to A over R, equation, according to equation number 1, it is equal to A over R. But A over R equals to 1 over R over A. Okay? Now we can substitute R over A, this R over A by tangent theta. We'll do it now and we'll get that according to equation number 1, tangent theta minus 1 equals to 1 over R over A, but R over A equals to tangent theta, so we'll substitute R over A in equation number 1 by tangent theta. In the next step we will multiply equation number 1 by tangent theta, and we'll get that tangent theta times tangent theta is tangent square theta, according to equation number 1, tangent square theta. Tangent theta times minus 1 is minus tangent theta, and it is equal to 1. Here we subtract 1 from this equation, equation number 1, and we get that according to equation number 1, tangent square theta minus tangent theta minus 1 equals to 0. So we got here a quadratic equation. In this quadratic equation, tangent theta is the missing variable. And the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X, it is actually equals to minus b plus minus square root of b squared minus 4 times ac over 2a. Okay, and in our specific quadratic equation, the coefficient a is equal to 1, the coefficient b is equal to minus 1, and the coefficient c is equal to minus 1 also. So, and this is the variable that we are looking for. X is equal to tangent theta. So we put the data inside this equation for x, and we find out the value of the values of tangent theta. We get that according to the formula for x, that tangent theta is equal to minus b. B equals to minus 1. So minus b is minus 1, that is plus 1, plus minus square root of b squared. B squared is minus 1 squared, that is 1. Minus 4 times a is 1. C is minus 1. Over 2a, it is 2 times 1, that is 2. So we found out the tangent theta is equal to 1 plus minus 4 times minus 1 is 4, and 4 plus 1 is 5. So inside the root we have 5 only. This is what is left. So here we will have two solutions that are possible for tangent theta. The first solution is the tangent theta equals to 1 plus square root of 5 over 2. And the second solution for tangent theta is that tangent theta will be equal to 1 minus square root of 5 over 2. Okay? So 1 minus square root of 5 over 2 is a negative number. So tangent theta is negative according to the second solution. If we focus on the right triangle NMQ in this drawing, we have here right triangle, and this angle equals to 90 degrees minus theta. And we know that all the angles inside a right triangle are positive angles. That is to say, this angle, that is one out of 3 angles inside the right triangle NMQ, must be a positive number. So 90 degrees minus theta is a positive, that is to say, it is greater than 0. It is greater than 0. It is a positive number. So here we will add theta to this inequality, and we will get that 90 degrees is greater than theta from one side. But here in the drawing we can see that this is angle theta, the angle that we are looking for. And actually this angle theta is also inside the right triangle NMQ, therefore it is absolutely a positive number. 1 out of 3 angles in a right triangle must be a positive number, so theta is a positive number, that is to say it is greater than 0. From the other side, theta is greater than 0, so we found out that theta is between 0 to 90 degrees. And the function tangents between angle 0 to 90 degrees, is tangent theta is positive number. In the range of angles between 0 to 90 degrees, tangent theta is a positive number, so tangent theta is greater than 0, while according to our solution we found out that tangent theta is negative. So we have here a contradiction. Here we found out that tangent theta must be a positive number, while according to the second solution we found out that tangent theta is a negative number. So we got here a contradiction, therefore this solution is incorrect solution. We will cancel this solution, and what is left is actually only this solution, that tangent theta equals to 1 plus square root of 5 over 2. And in order to find out the value of theta itself, we will operate the inverse function, the opposite function of tangents on the result, that is 1 plus square root of 5 over 2, and we will find out that theta itself is equal to 58.28 degrees. So in conclusion, we found out that the value of angle theta, the angle that we are looking for, it is equal to 58.28 degrees. In the next step I will summarize the lecture. Actually we wanted to find out the value of this angle, angle theta. We have here in the drawing a quarter circle, and inside this quarter circle we have square ABCO. We also have here angle AMB, that is the right angle, and angle BQC is angle theta, that is the angle that we are looking for, and we want to find out the size of this angle, angle theta. In order to find out the value of angle theta, we made the construction. We extended line segment MA by straight line, and we extended line segment QO also by straight line until they intersect with each other at this point. This is the intersection point between extended line segment QO and extended line segment MA. We defined the intersection point as point N. Then we completed the quarter circle to a semicircle. So we have here a semicircle, and inside this semicircle we have a peripheral angle. Angle NMQ is a peripheral angle, and the value of this peripheral angle is equal to 90 degrees. And according to rule number 1, any peripheral angle that is equal to 90 degrees must rest on the diameter. And because of the fact that peripheral angle NMQ is equal to 90 degrees, according to rule number 1, it must rest on the diameter. And angle NMQ rests on NQ. That is to say, NQ is the diameter, okay? So we found out that NQ is the diameter of the semicircle. Line segment NQ is the diameter of the semicircle. And the diameter of any circle is twice as large as the radius. So we know that because of the fact that this is a quarter circle, then QO must be equal to the radius. So we define the radius QO as R. Therefore, the diameter QN that is twice as large as the radius will be equal to 2R. QN equals to 2R, QO equals to R. And what is the value of ON? ON will be equal to QN minus QO. ON equals to QN minus QO. So ON equals to QN, that is 2R, minus QO, that is R. In conclusion, we found out that NO equals to 2R minus R, that is R. So ON equals to R. It is the radius of the semicircle. And in the right triangle, triangle NMQ, the sum of the angles must be equal to 180 degrees. Which angles we have here? We have here 90 degrees. We have angle theta. We have also angle NMQ. In total, the sum of those three angles must be equal to 180 degrees. We subtracted 90 degrees from this equation, and we got that angle theta plus angle M and O, in total, they must be equal to 180 degrees minus 90 degrees. It is 90 degrees. We subtracted theta from this equation, and we got that the size of angle M and O is 90 degrees minus theta. So this angle equals to 90 degrees minus theta. Then, because of the fact that NQ is the diameter of the semicircle, NQ as a diameter must be a straight line. Any diameter in the world must be a straight line. Okay? The diameter NQ is a straight line. NQ must be a straight line because it is a diameter. And we have rule number 2. The sum of the angles on one side of a straight line is equal to 180 degrees. Okay? So, if we focus on the upper side of the straight line NQ at point O, then the sum of the angles at point O on the upper side of NQ must be equal to 180 degrees according to rule number 2. Okay, at point O on the upper side of NQ, the sum of the angles must be equal to 180 degrees, that is to say 90 degrees plus the size of angle AON. In total, they must be equal to 180 degrees according to rule number 2. We subtracted 90 degrees from this equation, and we got that the size of angle AON is equal to 90 degrees. So this angle is a right angle. Likewise, if we focus on the upper side of the straight line NQ at point C, then the sum of the angles on the upper side of NQ at this point C, the sum of the angles must be equal to 180 degrees. So which angles we have at point C on the upper side of NQ? We have here 90 degrees, and we have also angle BCQ. So 90 degrees plus the size of angle BCQ, in total they must be equal to 180 degrees. We subtracted 90 degrees from this equation, and we got that angle BCQ is equal to 90 degrees. This angle is a right angle, it is equal to 90 degrees. Then we continue to focus on the right triangle, triangle BCQ. On the right triangle, triangle BCQ, we know that the sum of the angles must be equal to 180 degrees. So which angles we have here? We have here 90 degrees, we have here angle theta, and we have also angle CBQ. In total, the sum of those three angles must be equal to 180 degrees. I'll repeat again. 90 degrees plus angle theta plus the size of angle CBQ. In total, they must be equal to 180 degrees. We subtracted 90 degrees from this equation, and we got the theta plus angle CBQ equals to 180 degrees minus 90 degrees, it is 90 degrees. We subtracted theta from this equation, and we got that the missing angle, angle CBQ equals to 90 degrees minus theta. So we found out that this angle, the missing angle, equals to 90 degrees minus theta. Likewise, in the right triangle, triangle AON, the sum of the angles must be equal to 180 degrees. So which angles we have here? We have here one angle that is equal to 90 degrees, and we have angle that is equal to 90 degrees minus theta, and we also have here angle NAO. In total, the sum of those three angles must be equal to 180 degrees. I repeat again, one angle is equal to 90 degrees in triangle ANO. The other angle is equal to 90 degrees minus theta, and the third angle is equal to OAN in its side. In total, the sum of those three angles must be equal to 180 degrees. So we have here 90 degrees plus 90 degrees is 180 degrees. So we have 180 degrees in both sides of the equation, so 180 degrees will get cancelled. And we left only with minus theta plus angle ON equals to 0. We added theta to this equation, and we found out that the missing angle, angle OAN, is equal to theta. This angle, the missing angle, angle OAN, equals to theta. So we actually found out that all three angles in the right triangle OAN can join to all three angles in the right triangle CBQ. Why? Because both triangles have angle theta here. Both those two triangles have angle that is equal to 90 degrees minus theta, and both those two triangles have angle that is a right angle that is equal to 90 degrees. Therefore, all the angles of triangle ON can join to all the angles of triangle CBQ. Therefore, we can conclude from it that the right triangle, triangle ANO, is similar to the right triangle, triangle BCQ, according to angle similarity rule. And from the fact that those two triangles are similar to each other, we will conclude that CQ over AO equals to BC over NO. CQ over OA equals to BC over NO. What is the value of CQ? CQ equals to OQ minus OC. CQ equals to OQ minus OC. OQ equals to R, it is the radius of the semicircle. OC equals to A according to our definition. Therefore, we found out that CQ equals to R minus A. So if OC is equal to A, then all the other sides of square ABCO must be also equal to A, because of the fact that all the sides inside the square are equal to each other. All sides of a square are equal to each other. So all the sides will be equal to A. So we substituted CQ in equation number 1 by R minus A. So CQ equals to R minus A over AO. AO is also equals to A, so it is CQ over OA equals to R minus A over A, and it is equal to BC. BC is also A over ON, and ON is R. So in conclusion, we found out that R minus A over A equals to A over R according to equation number 1. We split this expression to two parts. R minus A over A equals to R minus A over A. Minus A over A is minus 1. So in conclusion, we found out that according to equation number 1, R minus A, R over A minus 1 equals to A over R. Then we focus on the right triangle, triangle NAO. In this right triangle, we know that tangle theta equals to R over A. I'll repeat again. In the right triangle, triangle AON, we know that tangle theta equals to R over A. Therefore, we can substitute R over A in equation number 1 by tangle theta. We substituted R over A by tangle theta. So we got that tangle theta equals tangle theta minus 1 equals to A, and in the original equation we have A over R, but A over R here, R over A minus 1 equals to A over R, but A over R is 1 over R over A. 1 over R over A. Now we can substitute R over A by tangle theta. We did it and we got the tangle theta minus 1 equals to 1, and R over A is tangle theta. So in conclusion, we found out that according to equation number 1, tangle theta minus 1 equals to 1 over tangle theta. We multiplied equation number 1 by tangle theta, and we got that tangle theta times tangle theta is tangle square theta. Tangle theta times minus 1 is minus tangle theta, and it is equal to 1. We subtracted 1 from this equation number 1, and we got the tangle square theta minus tangle theta minus 1 equals to 0. This is quadratic equation. If the missing variable, the variable that we are looking for is tangle theta, and the general formula for quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to the following formula. X, it is actually equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, a is equals to 1, b equals to minus 1, and the coefficient c equals to minus 1 also, and the variable that we are looking for is tangle theta, so x equals to tangle theta. So we put the data inside the equation for x, and we found out the value of the values of tangle theta. So according to this equation, we get that tangle theta equals to minus b. B equals to minus 1, so minus b is minus 1, minus 1 is 1, plus minus b squared B squared is minus 1 squared. Minus 1 squared is 1. Minus 4 times AC. Minus 4 times A is 1 and C is minus 1. So it is minus 4 times minus 1. Minus 4 times minus 1 is 4 and 4 plus 1 is 5. So in conclusion, we found out that tangent theta equals to 1 plus minus square root of 5 over 2. Okay, so here we'll have two solutions that are possible for tangent theta. The first solution is tangent theta equals to 1 plus square root of 5 over 2. And the second solution for tangent theta is tangent theta equals to 1 minus square root of 5 over 2. We will focus on the second solution. In the second solution, tangent theta is a negative number because 1 minus square root of 5 over 2 is a negative number. And here, if we focus on the right triangle N and Q, so this is a right triangle with one angle that is equal to 90 degrees minus theta. And we know that all the angles inside a right triangle are positive angles. So we can write down that angle 90 degrees minus theta is a positive number, it is greater than 0. But from the other side, you have here angle theta that is also, this angle is inside a right triangle, and we know that all the angles inside a right triangle are positive angles, therefore theta is a positive angle, that is to say it is greater than 0. So from one side theta is greater than 0, and from the other side it is less than 90 degrees. And in this range of angles, the function tangents is a positive number. I will repeat again, in the range of angles that are between 0 to 90 degrees, tangent theta is a positive. So tangent theta is a positive number, but according to the second solution, we found out that tangent theta is a negative number. So we have here a contradiction. Therefore, this solution is incorrect solution. We will cancel this solution and we will focus only on the solution that we found here, that tangent theta is equal to 1 plus square root of 5 over 2. So if tangent theta equals to 1 plus square root of 5 over 2, then theta itself, in order to find out the value of theta itself, we will operate the opposite function of tangents, that is inverse tangents, on the result, that is 1 plus square root of 5 over 2, and we will find out the value of theta itself. So we operated the inverse function of tangents, the opposite function of tangents, on the result, that is 1 plus square root of 5 over 2, and we found out that angle theta itself equals to 52.28 degrees. So in conclusion, we found out that the missing angle, the angle that we are looking for, equals to 58.28 degrees. I repeat again, this angle theta is equal to 58.28 degrees. Okay? Thank you very much.